Researchers have identified a fascinating six-planet system that offers a different take on planetary configurations. The newly reported configuration features 6 planets around a single star. Their orbits line up in a synchronized manner, which astronomers call resonance. When planets move in resonance, their orbital periods stay in a fixed ratio for millions or even billions of years. This pattern can be so exact that it reminds some observers of musical tempos. Spotting this kind of rhythmic harmony helps scientists figure out why some stars gather families of planets that have stood the test of time. The analysis was led by Raphael Luke from the University of Chicago. Known as HD110067, this star sits approximately 100 light-years away in the northern constellation of Coma Berenices. Astronomers first recognized unusual dips in the star's brightness when NASA's Transiting Exoplanet Survey Satellite, or TESS, started surveying that region. Each tiny dip hinted that one of the star's planets was crossing its face. Data from both TESS and the European Space Agency's Characterizing Exoplanet Satellite, or CHEOPS, revealed something rare: a neat chain of 6 sub-Neptune planets in close orbits. This discovery is going to become a benchmark system to study how sub-Neptunes, the most common type of planets outside of the solar system, form, evolve, what are they made of, and if they possess the right conditions to support the existence of liquid water on their surfaces, remarked Luke. Many stars in our galaxy hold at least one planet that's bigger than Earth but smaller than Neptune. These in-between worlds are often called sub-Neptunes, and they're more plentiful than massive gas giants like Jupiter. Scientists are intrigued by this class of planet because it covers a range of possible compositions. Some might hold thick gas envelopes, while others could have dense, rocky surfaces. Observing these in sync can show how these planets get locked in place and remain that way for an incredibly long span of time. Resonant systems form when planets start out with orbits that nudge each other in a balanced way. Small gravitational pulls set up a regular rhythm. But big objects or random gravitational jostling can break these patterns. That makes resonance a tricky arrangement to maintain. Astronomers estimate that only about 1% of multi-planet systems preserve this stable choreography. Not all stars are lucky enough to keep their planetary brood free of turbulence. Some lose this delicate pattern when a larger planet barges in or when stars drift near one another. The lack of large neighbors in HD110067's environment might have helped these 6 sub-Neptunes remain nestled in their precise arrangement for so long. Without any violent intrusions, the orbits can carry on as they have since formation. This level of cooperation in one system could provide hints about how others might form or break apart. For experts who study planet formation, every new system that shows a clear pattern provides more evidence about how dust and gas swirl together and eventually become planets. Some calculations suggest planets might typically start in resonance, but migration and collisions can make them drift. An untouched system paints a cleaner picture of early planet building. Pinpointing each planet's mass and density can also highlight the proportions of rocky materials, water, and gas they contain. Researchers plan to keep a close eye on HD110067's planets using more precise techniques. Improving measurements of the planet's masses and densities will help astronomers to figure out what these sub-Neptunes look like on the inside. Deeper analysis can also show whether any might have conditions that allow water to stick around on the surface. These tasks will probably involve instruments on large ground-based telescopes and future space observatories. Astronomers hope the data from this oddly balanced system will reveal reasons why some worlds remain in tight-knit formation, while others never stabilize. Stumbling upon a collection of planets that circle in smooth synchronization gives a glimpse into the hidden patterns that shape the galaxy. This compact group orbiting HD110067 might be just one example of what sub-Neptunes can do when left undisturbed. Folks who are fascinated by the way planetary families and planet systems form see this system as a chance to learn. It challenges scientists to look for other hidden resonances in our galaxy and sparks the question of how many have slipped past our detection. Find a link to the full article on Earth.com in the description.